Hello, everyone. Welcome to the last day of Unit 3. Today we're going to talk about the average rate of change. So the average rate of change is the change in y over the change in x over a designated period. Because these are not for linear functions where it's a constant. So we can only do it if we have a beginning and an end. When we model using the functions, we're very interested in the rate of change that the output is changing compared to the input. So this is change in y over change in x. So to evaluate, so here's our function. We want to evaluate the following based on the graph. So f of 0, remembers when we go to the x-axis at 0, and we find the value, and that's 1. F of 4 is when we go to 4 on the x-axis and we go up to the graph, which is 7. So I want you to pause and I want you to find f of 7 and f of 13. So hopefully you found that f of 7 is 10 and f of 13 is 15. So for part B, it says find the change in the function. So in delta f, so that's just what's our increase of the change in y over each of the following intervals. Find this by both subtracting and the graph. So if I look at from 1 to 4, I went up 6. And I would do that by doing 7 minus 1, which is 6. From 4 to 7, I would do 10 minus 7, which is 3. 7 to 13, I'm going to do 15 minus 10, which is 5. So if I look at those, the largest change happened from 0 to 4. But that doesn't necessarily mean that that had the largest rate of change, because you can't simply compare the changes in f from part B, because we need to know over how long. Just because it changed the most didn't mean it changed the fastest. So in order to find the average rate of change, what we're going to do is we're going to do that change in f over change in x, or change in y over change in x. And we can do that by doing our change in f, which was 6 that we found in there, over how much x changed, which is 4. So that's 3 over 2. This is 3 over 3, which is 1. And then 7 to 13 is 5 over 6. So the beginning part is when it had the largest rate of change. So the average rate of change is an exceptionally important concept in mathematics because it gives us a way to quantify how fast a function changes on an average over a certain domain interval. Although we used its formula in the last exercise, we stated formally here. For a function over the domain a to b, the function's average rate of change is calculated by the delta f, change of the output, over the change in the input. So it's f of b minus f of a over b minus a. So if we're going to consider these two functions, calculate the average rate of change for both functions over the following interval. We need to work carefully and show the calculations. So if we do f of x here, we're going to do f of negative 2, which is 5 times negative 2 plus 7. Because remember, when we're doing f of a value, we substitute, which gives me negative 3. Then I want to do f of 3, which is 5 times 3 plus 7, which gives me 22. Now to find the average rate of change, I'm going to do 22 minus negative 3 over 3 minus negative 2. The change in the f over the change in the x. So that gives me 25 over 5, which is 5. Then to do g of x, we're going to do g of negative 2, which is 2 times negative 2 squared plus 1, which is 9. And then we're going to do g of 3, which is 2 times 3 squared plus 1, which equals 19. And then the rate of change there is 19 minus 9 over 3 minus negative 2, which is 10 over 5, which equals 2. Then we're going to do this other example. So we're going to do f of 1, which is 5 times 1 plus 7, which is 12. Going to do f of 5, which is 5 times 5 plus 7, which equals 32. Then it's 32 minus 12 over 5 minus 1, which is 20 over 4, which equals 5. That's our average rate of change. Then we're going to do g of 1, which is 2 times 1 squared plus 1, which is 3, and g of 5, which is 2 times 5 squared plus 1, equals 51. So our rate of change there is 51 minus 3 over 5 minus 1, which is 48 over 4, which is 12. So it says the average rate of change for f was the same in both 1 and 2, but was not the same for g. Why is that? So the reason is f of x is linear because it has an exponent of 1 on x. Therefore, it has a constant rate of change. So it doesn't matter what interval we use. G of x is not linear, is nonlinear. Therefore, the average rate of change will change. Varies depending on the interval, the domain interval. So we have a couple more examples here that I want you to try. So pause and try them and come back and check. Okay, so for number 3, to complete the table knowing it's a linear function, that means I need to start by finding my constant rate of change. So I used the first 2 points and I found my constant rate of change is 3 over 2, which means they all need to change with a ratio of 3 over 2. So from 5 to 11, I increased 6, which means my x went up by 6. So in order for it to reduce to be 3 over 2, it needs to be 9 over 6. So I added 9 to the y. Then from 10 to 22, I added 12. So in order for my y to increase by 12, my x needs to increase by 8 in order to maintain the ratio of 3 over 2. And then last but not least, 19 to 45, I increased by 26, which means my y had to increase by 39, again to maintain the ratio of 3 over 2. Number 1, to find my rate of change from negative 1 to 6, I did 12 minus negative 2 over 6 minus negative 1, and that gave me 2. To find the rate of change from negative 3 to 9, I did 5 minus 8 over 9 minus negative 3, which gave me negative 3 over 12, which is negative 1/4. Answer to D is the average rate of change is different, therefore that is not a linear relationship. Number 3, to find the average rate of change from 5 to 7, I did the change in the function, so 64 minus 20 over 7 minus 5, which gave me that the speed there is 22 feet per second. The average rate of change when we're talking about distance and time is speed. So my speed from 0 to 5 is 4 feet per second. My speed from 11 to 14 is 5 feet per second. Therefore, in this 11 to 14 time period, they're going faster. If you have any questions, please bring them to class tomorrow.